Ever heard of the secret zero paradox? If your applications run outside the cloud, so on VMware, physical servers, or legacy systems, you know how challenging it is for machines to safely get their first secret when talking to a secret manager. Without built-in identities, you're stuck manually managing static credentials, creating massive security risks and endless headaches. But today, I'll show you exactly how to solve the secret zero problem with Akeyless Universal Identity, securing non-human identities effortlessly, even outside the cloud. Keep watching because your days of static secrets are over. Let's get started. Solving non-human identity management with Akeyless Universal Identity. Let's talk about the non-human identity crisis, and we're focusing on non-human identity as opposed to humans logging in and accessing secrets and so on. We're talking about machines that need access to other machines and access to secrets in general. So the problem is static secrets or static keys are rarely changed. They're very risky, and API keys will fall under this category. Regular secrets would fall under here. Service accounts that you use with your applications would also fall under this category. It's a manual process, slow, error-prone. You need admins that will create those service accounts per application. They're static most of the time, and it's hard to rotate and so on. There's an identity gap. Machines lack proper identity. And the human-focused solutions that we have are really not built for machines. And why is that? It's because machines are always on. They need constant automatic authentication. And they're massive in scale. Think of thousands of services or microservice that you need to secure. Let's talk about a challenge, and this challenge is called the Secret Zero Challenge. Really, what is Secret Zero? How do you safely get the first secret? So if you're working with a secret manager and you want to retrieve secrets from that secret manager, well, guess what? You have to log into that secret manager. So the paradox is you need credentials to get credentials, right? And that is really not a very easy problem to solve, especially depending on what environment your applications are running on. So if you're running a cloud native setup, your apps are in an AWS EC2 instance or running in EKS or in ECS and so on. AWS has a very elegant solution with IAM where it actually provides an identity to the resources that it spins up. So the EC2 instance has an ID, a fingerprint inside of it that you can authenticate against, and that is the identity. So you can tie that into Akeyless, and Akeyless can authenticate and say, hey, I know this particular EC2 instance because it talks to the AWS API and then verifies your application directly and solves that secret zero problem elegantly. Azure has something similar, Kubernetes has something similar, and Google also has something similar. The problem is when you run into a non-cloud native environment, such as VMware, physical servers, legacy systems. So these platforms don't provide identity to the VMs or machines that they spin up. And this becomes an issue. How do we actually give an identity to those machines so they can log into Akeyless and then retrieve the secrets that they need? And the reality is that 70% plus of workloads lack built-in identities. Now, why do current solutions fail? Because again, static secrets can be saved in files. You don't want that. And then credentials might also be hard-coded inside of variables, inside of your code, because it's a difficult problem to solve. Now let's see the solution from Akeyless perspective with Universal ID. And this chart here shows you different personas that are involved in setting all of this up. So we have an administrator of Akeyless, we have a platform engineer, an application service or application service owner, and then the Akeyless SaaS backend. So let me walk you through this diagram really quickly because this is important when we start to look at our demo. The Akeyless admin needs to initialize this whole setup one time. They need to create a UID authentication method inside of Akeyless. Akeyless responds back with an acknowledgement, and then the admin needs to generate a universal identity or a UID token, and the SaaS gives them back the token. At this point, the admin needs to hand off this UID token, and the UID token is tied to one application. All right. So one UID token per application needs to be delivered to the platform engineer. And at this point, the platform engineer needs to deliver this token to the place where the application is going to eventually run. So if it's a VM inside of VMware, they need to put this UID token in a file there somewhere. So then they need to set up an automated rotation script that will go ahead and rotate this UID, because again, we don't want it to live forever. It should not take more than 60 minutes to live. You should have that TTL that's configurable, of course. All right, so at this point, you do this once per application, and then now the application has access to this UID so that they can log into Akeyless and retrieve the secrets they need. So at this point, starting in step 4 here, the application can authenticate with this UID token, and then they get a response with a short-lived JWT token. Think of this as a session token that is even shorter than the UID, where they can use this JWT token to retrieve the secrets that are stored in the SaaS backend inside of Akeyless. So now we're going to use the T token to retrieve some database secrets, and the flow stops here for the application. But we can also add a self-rotation cycle inside of the application. So if you want to code that in the application, you can. If you don't, then you can rely on the automation scripts that the platform engineer has put in place. So it really depends on whether you want to include that in the code or not. Now, in addition to this, we have this concept of hierarchy. So you can actually create child tokens for microservices and then manage the hierarchy of the service identity. And basically, we'll talk about this more in the demo, but this is very useful where you can have one application that has multiple microservices, and you want to isolate the identities of these microservices so you can generate child and grandchildren for the tokens for those microservices. All right, so the benefits of using universal identity versus our traditional approach, I'll walk you through these features, starting with rotation. So you can see with universal identity, we have automatic rotation with TTL that we can reset, whereas the traditional approach is a manual process. From a hierarchical access perspective, what I just mentioned regarding microservices, there's a parent-child relationship, and we can revoke that, and we can generate it, of course, whereas it's a flat structure with a traditional approach. From an auditability perspective, we have a complete token lifecycle logs. In case of traditional approach, it's very limited in visibility. Revocation, I touched on that, so immediate granular control, whereas traditional approach, it's a system-wide impact that can happen. Think of having multiple service accounts that you have to revoke. That could be dangerous, and the reality is many times you have a service account that is indefinite, which is pretty scary, and it has a very large blast radius. The TTL management is built-in expiration inside of universal identity, whereas there's no expiration usually with the traditional approach. And then child tokens provide service isolation per microservice. Usually you have a shared credential across all your microservices because you have one service account per application. And then the secretless operation, we really have no static identities. We have no static secrets here. They're always being rotated on a regular basis. Whereas, of course, we are forced to have static credentials if we're running with a traditional approach with, again, VMs that are not part of a platform that gives identities to its resources. All right, with that, let's go ahead and jump into our demo. All right, let's go ahead and get started with our demo. And I have on the right-hand side our 3-persona workflow that we just went through. It will help us as we go through this demo. So if you go ahead into our repo and just run the start script, and we have different scenarios. And as you can see, this is a guided demo that follows the realistic workflow diagram that we have on the right-hand side. The admin, the platform engineer, and the application service. We're going to go in and choose options 1, 2, 3, 4, 5 in order. So the first thing we want to do is go ahead and put on our admin hat as an Akeyless admin that needs to run through these first 3 steps. So go ahead and choose number 1. And this is going to go and run a script behind the scenes that does all of this for us. It's going to create the UID auth method, it will generate the UID token, and it already did all that. So let's go ahead and see what exactly happened. All right, so this script represents the admin persona from the workflow diagram. Admin creates the UID auth method, generates initial UID token, and provision the token to the client machine. So this is going to be passed over to the platform engineer. So what happens? We have authenticated into Akeyless using our admin authentication method, and we've successfully done that. We are going to create the UID authentication method, and we did that already, and now we can see the access ID for that method is here. And this is the path for this method. And down here in step 2, the admin creates a demo secret and access policies. So for example, we have a database config secret that we've created that the application is going to use to retrieve some secrets. We also created a role, an access role that is tied to the authentication method. And this is the role that allows the application to retrieve the secrets here at this path. All right, so that was all done successfully. And now the admin generates this UID token using this command, Akeyless UID generate token. And this is the auth method that we were using. Here's the token we got back. This is the UID token that we got back. And then we've saved this in this particular file, tokens, client tokens. So if I expand this and look at it, here's our token. All right, so here's the UID token that we just created with the access ID and the auth method and so on. So that file now needs to be passed over to the platform engineer, right? So we're right here where we need to hand over to the platform engineer this file so the platform engineer can pass it onto the application wherever the application lives, and we can get started with bootstrapping our application. All right, perfect. Let's hit enter. We're back to our screen. We finished the admin setup step. So now let's move on to the platform engineer deployment step. That's step number 2. Type 2 and enter. So platform engineer deploying the UID to the application service. So this is pretty straightforward. All we need to do is get the UID token and access ID and auth method from the Akeyless administrator and then deliver this to our application. So in this demo, as just to show you that this is being done, we've already done that and we've dropped it into this file here. We call it the application service token file, and it's pretty much the same file that we saw the client tokens that we got from the previous step. But not only that, the platform engineer also configures an automated rotation script. So under scripts here, I have a script for auto rotation. So this will auto rotate that UID for us. So you can see the script is all right here if you want to take a closer look. But not only that, we also have a cron job that is going to run on that machine to automatically rotate the UID for us. And again, this is optional depending on whether you want to include the rotation logic inside of your application or if you want to have it outside of the application. All right, so we've done that. And then finally, step 4, the platform engineer tests the application service setup. So run a quick test with the UID. So you have the access ID, the UID, and then you get back a test token here, this T token right here where the application is going to use it. It's just a quick test to make sure that the authentication method works and everything looks good. All right, so with that, we basically finished the platform engineer's job here and deployed the authentication UID token onto the application, and we're ready to move on to our next step. So now we've deployed the UID token to the application server, and now we're going to go ahead and type 3 to go into the application service operations step, which is really steps 4 through 9 on our diagram. So that is also completed successfully. So let's see what exactly happened here. We can see that we're starting off with the UID token. So the first thing we want to do, make sure that we're not running any kind of admin credentials at all. So we're making sure that's the case. So loading application service tokens that deployed by the platform engineer. You can see this is our UID and access ID. Configuring gateway without admin credentials. So authenticates, the application service authenticates using the admin provided UID token. And we run this command. Let's just make this a bit smaller here. So Akeyless auth access ID, give it the access ID. The access type is universal ID, and then provide it with the UID token. When you run this command, you're going to get back this output, authentication succeeded with a token. This is our T token, the JWT token that we're talking about right here. So now step 5 is we got the JWT token successfully. Step 6, we're going to use now the JWT token to, guess what? Get our database secret, right? That's really the intent here. So we can run the command Akeyless get secret value and where that secret lives. And then the token we're providing is that T token that we just talked about. And here we go. Here's our output. We get back our database secret. Step 7, this is, again, if you want to embed the logic of rotating that UID token inside of your application. So you can run the command Akeyless UID rotate token, provided the UID token, and you get an acknowledgement back with a new UID token. All right, now you can save that new ID token into our tokens file. So back here, this will be the new UID token, as you can see, the one we just got back. All right, so we're persisting that so that whenever the application needs to restart or if it needs to talk to Akeyless again during the life cycle of that application, it knows where to get the UID token to create a new T token and so on. All right, so here we go. Akeyless auth access ID. We provide the access ID. The access type is universal identity. Provide the UID token. We once again get our T token, and the cycle continues on and on. And from here, we want to just run one more step here to verify that our old UID token is invalidated, and that is successful. We can see that we've correctly invalidated the old UID. Perfect. So the application service workflow has completed successfully. We've pretty much gone through this whole thing. What's left is a couple more demos. The first one is hierarchical token management. So let's run this one with 4. And what this is going to do is it's going to show us how we can create child and grandchildren tokens that can be tied to microservices. And what this is going to do is it's going to create child and grandchildren tokens that can be tied to microservices. So here we go. Our demo starts here, child tokens demo. And we're going to create application service creates child tokens for microservices for service isolation. We're going to view the token tree structure. We're going to use the child tokens for authentication for independent TTLs, and then demonstrate how we can revoke a child token on its own or a child token with all its children and grandchildren. Let's go ahead and see what happened. We've loaded the application service tokens that the platform engineer provided for us. Here it is, application service loaded. This is the one we got from the tokens file here. And step 1, we're going to check and see our UID token by running this command, Akeyless UID list children, and provided the UID token. You can see that we have only one token and it's root. So it doesn't have any children or grandchildren. So next step is to create a child token with this command, Akeyless UID child token, provided the UID and the child TTL. And let's say this represents a database microservice. And here we have our child token right there. Then let's create another one. And let's say this one represents an API gateway. So it gives us another token. And another one. And this one is actually going to be a grandchild token, and it's going to be a child of the database token. So if you notice here, we're using this token, which is the same one as this one here. So the database microservice is going to spin up its own child token for a database cache service. All right, step 5, application service completes token tree structure. So we're going to run the same command we saw before, and now we have 4 tokens. And we see our root token, and that root token has a child token for the database, And that child token for the database has a grandchild token for the database cache. And here's our API gateway, which is a direct child token of our root token. So now we can see that we have a hierarchical tree of tokens that are used for isolation between different microservices. Step 6, testing the application service child token authentication. And as you can see, we can test now with the command Akeyless auth, provide the access ID, the access type, and the UID token now is the database microservice. And of course, we get back our JWT token. So that worked perfectly. We do the same with the database cache, and we get another T token successfully. And now we get to see how to revoke the child and grandchild tokens. So we can go ahead and revoke the API gateway child token with this command, Akeyless UID revoke token with the token ID, revoke type, revoke self, and provide the path for the auth method right there. And you can see API gateway child token is revoked successfully. Now we see the tree has only 3 tokens, right? And we have removed the API gateway, but we still have the database and the database cache. So we can do this once again. And we're going to revoke the database. And this database will revoke the database cache automatically. So it'll revoke this child, and this child will revoke its child automatically. And you finally run to see what is left. And we only have the root token, in this case, left for us with no more child or grandchild tokens. Perfect. Now, when would you use hierarchy like this? There are a few real-world use cases that we can use this with. I mentioned microservices architecture. That is one. And there's, of course, another one with container orchestration, where you can have the parent token as an application deployment. The child tokens can be individual container instances. Also, event-driven processing, where an event processor application service is the parent token. And then child tokens can have short-lived event handler functions. And then finally, a multi-tenant application with the parent token being an application service, and then one per tenant. And then child tokens will be feature-specific access with tenants. And then finally, let's take a look at the Python integration example. And this is a real-world application that you can basically integrate universal identity into your application. So we have a few scenarios here. The first one is just a basic secretless authentication and secret retrieval, where we're exchanging our UID token for T token. And by the way, this is found in the examples folder here. So here's our Python code if you want to go back and take a look at it closely. But basically, like I said, we're getting our T token from the UID. So the exchange happens successfully. And then we're going to retrieve the database configuration, as you can see here. That is done nicely. Also, we demonstrate how to rotate our token. In this instance, we're actually embedding the rotation logic inside of our application. And then child token management, where we can create child tokens as well. So we're doing that within the Python app as well. And then here's a more detailed example where we're grabbing the database config, and then we're actually logging into the database and then doing something with the database, in this case, running a select all from the user's table. And that is pretty much it from this demo's perspective. I wanted to include this one because it shows you in a real world scenario how you can integrate Akeyless' universal identity into an application that you can run with, where in this case, this is an Akeyless aware application that we've implemented rotation inside of it with child token management and everything else. So this could be a really good example where you can start with, and of course, depending on what programming language you're working with, you can leverage that kind of logic directly into your application. But again, you don't have to. You can leverage the automation script that I mentioned before to get this running out of band, and then your application doesn't need to be aware of all of that. All it needs to know is where that UID lives to use it, and then access Akeyless directly. And that's how you finally put an end to the secret zero paradox, especially for your non-cloud native environments. By implementing Akeyless Universal Identity, you've transformed machine-to-machine authentication from a risky manual process into a secure automation solution. Remember, no more static secrets and long-lived secrets. No more manual rotation, and a safer, scalable way to manage non-human identities. Thanks for watching, and I'll see you in the next one.